All right, we're going to continue with arithmetic sequences. In the last one, it was kind of an introduction. It was a quick introduction, but I talked about what an arithmetic sequence is. It's one with a common difference. To contrast it, I'd let you know what a geometric sequence is. We'll get back to that at some point. Here's an example of what, whenever you can see that there is a pattern, you can find that there's a common difference. We call that D. And given all that information, we can come up with this formula that can give us any term of any list. That's arithmetic. So I'm going to start there. There's that formula again. This is called an explicit formula, right? This is the explicit formula. You might hear that phrase. So I want to make sure I say it a few times. A sub n is just the nth term. So if I wanted to find a fifth term, for example, n would be 5. The first term is a sub 1. That's the first term. D is the common difference. And then n, again, is the number of the term. So I could use that information and ask you to find the explicit formula for this thing. First off, we see that from 3 to 7, if I do 7 minus 3, I get 4. 11 minus 7, so if I subtract it, I get 4. If I subtract it, I get 4. If I subtract it, I get 4. Looks like I have a common difference. That tells me that D is 4. All right, I'm going to change the writing here. It tells me that D is 4 just by looking at my list. So this is arithmetic. That means I can try to fill in my formula, right? This is the general explicit formula. If I wanted to find any term, I would need the first term. Well, what's the first term? 3. So I would find 3 plus D. We said D is 4 times n minus 1. Done. That's all I need to do. If I wanted to find the nth term, the explicit formula for the nth term, all I really need is the first term and the common difference. That's all I really need. Now this one goes further. This question goes a little further, and it says, first find the explicit formula, check, then find the 20th term. So the 20th term, that means a sub 20, because I want n to be 20. So that means I'll do 3 plus, I'm going to use this thing, 4, and instead of n, I can go ahead and write 20 minus 1. Let me simplify that. 3 plus, and then if I did this is 4 times 19. 3 plus, and this is going to be a 76, I think, which is 79. If I were to write these terms out, if I continued adding 4, and I did it to the 20th number in the list, I would get 79. Okay, that's how you use the explicit formula to find another term. Let me see here. I have Alex open. Let me see if there's anything in particular. So this one is just that. Find the 73rd term of the following arithmetic sequence. Well, we just kind of did one of those. Let me see if there's anything different and unique about these. Find the 13th term of an arithmetic sequence with a common difference of 6 and the first term of 4. Well, it's the same kind of problem as well. See what 7 is talking about. Write an explicit formula for the nth term. Well, that's the same kind of problem. Good. And here, write an explicit formula for these. All right, same deal. In the beginning, I think it's more along the lines of just, is this arithmetic or not? So I should do, in fact, let me just do that here. Is this one arithmetic? If I have negative 3, negative 15, negative 75, negative 375. If I do this to this, so that means negative 15 minus negative 3 minus this one. That's a plus a positive, that's negative 12. Let me do the same thing here. Negative 75 minus negative 15 plus a positive, that's going to give me a negative 60. Well, right away, this is not a common difference. So not arithmetic. So if I did that with all of these numbers and this number was the same, I would say is arithmetic. This one is not. What about the next one? Let me see if I can do this one quickly. If I'm looking at these, I have negative 29, negative 22, negative 15, negative 8, dot, dot, dot. Uh-oh, very quickly. Negative 22 minus negative 29. That's this. That's going to give me a boom, boom. That's going to give me a positive 7. What about negative 15 minus negative 22? Boom, boom. Oh, positive 7. And if I continue, I'll see I'll have a common difference. The answer is yes. And the common difference is 7. I'm not going to click check because it's going to say the last one's